Hello friends, I Prof.Darshan.B.Thakur from Terna Engineering College, Dharashiv welcomes you on my YouTube channel for this subject here, digital communication. As far as our today's session is concerned, so we will try to learn this basic phenomena which is being adopted by this pulse modulation scheme, because as far as these pulse modulation schemes are concerned, so the objective behind this pulse modulation scheme is to learn how to transmit the analog information signal in a digital form. So this analog to digital conversion involves this process that can be called it as a quantization. So first question arises in our mind ki what do you mean by this quantization, right? So the simple answer for that question is nothing but what the quantization is the process in which the unquantized input sample is being approximated to the any particular digital level, which results in minimum distortion or which results in minimum error. That whole quantization process is to be done with the help of this fellow whose name is nothing but what quantizer. So the finite number of digital levels are being exclusively stored within that quantizer itself. So accordingly, this quantization is broadly classified into two different types. First one is nothing but what the uniform quantization, and second one is nothing but non-uniform quantization, right? So today we will talk about this first type of quantization whose name is nothing but uniform, right? So uniform means, as its name indicates, the desired quantization step or the difference in between any two quantization levels is same throughout the entire amplitude range covered by that unquantized input signal. That is nothing but what? Uniform. Non-uniform means what? According to our own convenience, we can adopt the desired step size according to the amplitude of that signal. That is nothing but what? The non-uniform quantization. So first we will talk about this uniform quantization. Again, this uniform type of quantization technique is divided into two different types. First one is nothing but what? The mid-trade quantizer, and second one is nothing but what? The mid-riser quantizer, right? So as we know, we are very much aware of this thing ki, either in case of pulse code modulation, differential pulse code modulation, or the delta modulation, what exactly we are doing? Our aim is to transmit the analog signal in digital form. So accordingly, as you can see, this is the transfer characteristics of mid-trade type of quantizer. Transfer characteristics means what? It is the plot in between two different parameters, right? And these two different parameters are nothing but what? Within this x-axis, we used to have the x of NTS. X of NTS is nothing but what? The unquantized input sample. And within this y-axis, we used to have the xq of NTS. xq of NTS stands for what? The different quantization threshold, those are being stored within that quantizer. So this quantizer will have tendency to assign any of this digital threshold to that current value of that sample during each and every signaling interval, right? Now the question arises why it is being called it as a mid-trade type of quantizer, right? So as you can see, this is nothing but what? The staircase approximated waveform, right? As far as the staircase approximated waveforms are concerned, those are being divided into two different parts. This is nothing but what? This is the trading portion of this staircase approximated signal, and this is nothing but what? The rising portion of the staircase approximated signal, right? If you see carefully, as far as this origin is concerned, so this origin is lying at the middle point of this trading part of this staircase approximated signal, right? When the origin is being located at the center point of this trading portion of the staircase approximated signal, that's why it is being called it as a mid-trade type of quantizer, right? At this origin, x of NTS equals to what? X of NTS equals to 0. Means input equals to 0. When x of NTS equals to 0, at that time the output of quantizer is also how much? It again it equals to 0. Means when x of NTS is equals to 0, so xq of NTS is also equals to 0. Means at this origin the quantization error is also 0. Here the quantization error is nothing but what? The quantization error, which is denoted by this epsilon sign, this is the difference in between xq of NTS minus x of NTS, right? So initially xq of NTS is also 0 and x of NTS is also 0 at this origin, at this location. So At this origin, quantization error is also how much? The quantization error is also 0. Now, as this input is approaching towards the certain positive value or towards the certain negative value, then what will happen when input is approaching towards, as far as this x-axis is concerned? So as you can see, these are the different amplitude levels. Those are being assigned to that unquantized sample, which ranges from -7 delta by 2 to the +7 delta by 2, right? As far as this y-axis is concerned, so the number of different thresholds those are being stored by that quantizer are ranges from -4 delta to +4 delta. This is for our convenience only. And what we need to remember, that this factor quantization error is nothing but what? It is the difference in between xq of NTS and x of NTS for that particular instant of time, right? So at this origin, quantization error is exactly equals to how much here? 0. Now, as this input is approaches towards the certain positive value or to the certain negative value, means for if suppose when this x of NTS, as you can see, when this x of NTS is lying in between plus delta by 2 to plus 3 delta by 2, at that time what will happen, or initially before that, when this x of NTS approaching towards the plus delta by 2, so at that point again which step size is being selected by that quantizer? It will try to assign the nearest quantization level, or it will try to assign the nearest threshold to that current sample, which results in minimum error. So what it will do, it will try to assign this quantization level called as a delta when input is exactly equals to, or it approaches towards the first positive value, that is nothing but what? Delta by 2. Now similarly, when input is lying in between delta by 2 to the 3 delta by 2, at that time what will happen? This quantizer will decide the nearest possible value, that is nothing but what? 2 delta, right? When this input is approaches towards the minus delta by 2 to the minus 3 delta by 2, at that time what will happen? This quantizer will come to know that this minus 2 delta is nothing but what? It is the nearest distinct or the nearest digital value assigned to this sample, which lies in between minus delta by 2 to minus 3 delta by 2. So this is nothing but what? The process of quantization, right? And see, as far as this infinite slope dotted line is concerned, so what it will try to indicate? It will try to indicate the maximum value of this quantization error, right? The maximum value of quantization error is how much, right? When input equals to 0, quantization error is exactly equals to 0. When input is approaching towards the plus delta by 2 or towards the minus delta by 2, so at that point which nearest digital value is being assigned by that quantizer? Either delta or plus delta. So Emax equals to what? It is delta minus of delta by 2, right? Or it is minus delta minus of delta by 2. So within each and every case, the maximum value of this quantization error is how much here? The maximum value of this quantization error is mod of delta by 2, right? Means we are coming on to this conclusion that the maximum value of this quantization error for this mid trade type of quantizer so from this discussion, the maximum value for this quantization error for this mid trade type of quantization process is nothing but what? It is mod of delta by 2. As far as this infinite slope dotted line is concerned, if I highlight this portion like this, again here it will become plus, again it will become minus, then again it will become plus, minus. Right. So see this, as far as this highlighted portion is concerned of the staircase approximated signal, it indicates that much amount of error is being emitted by this quantizer itself during each and every signaling interval while deciding the nearest digital value to this particular sample. right? So this is all about this mid-trade type of quantizer. Then we will talk about the mid-rise type of quantizer. Okay, so the next type of uniform quantization is nothing but what? As you can see, the mid-riser type of quantizer. This is the second type of quantizer which was used in case of this uniform quantization process, in which the quantization step or the difference in between any two quantization level is same throughout the entire amplitude range of this unquantized input sample. So let us quickly go through the transfer characteristics of this mid-riser type of quantizer as compared to the mid-trade type of quantizer. Again, this transfer characteristics means it is the plot in between this xq of NTS, output of this quantizer, and x of NTS, means unquantized input which is being given to the input of that quantizer, right? So again the question arises in case of this mid-riser type of quantizer, why it is being called it is as a mid-riser, right? So the simple answer for that question is nothing but, if you see carefully, the origin of this transfer characteristics is lying at the middle point of this rising portion of this staircase approximated signal, right? As I told you earlier, this is the trading and this is the rising part of the staircase approximated signal. So here the origin is located at the middle of this rising part of this staircase approximated type of signal. That's why it is being called it is as a mid-riser type of quantizer, right? Now again, when input is approaching towards the certain positive value or towards the certain negative value, when input is lying in between 0 to delta, means when, as we can see, when this x of NTS is greater than or equal to 0, greater than or equal to delta, at that time what will be the xq of NTS? See, quantization is nothing but what? It is the process of approximation. So when the input is lying in between either 0 to plus delta or either 0 to minus delta, at that time what will happen? Whether it is plus delta or minus delta, the nearest possible threshold assigned by that quantizer will be what? Either it is plus delta by 2 or either it is minus delta by 2. So x of NTS equals to what here? Plus delta by 2 or minus delta by 2. So this is the basic logic of this mid-trade type of quantizer. Remaining things are just exactly similar to the mid-trade type of quantizer, right? Again here the maximum quantization error equals to what? What this maximum quantization error, that is nothing but what? The difference in between xq of NTS minus x of NTS, right? Now when input equals to 0, when x of NTS equals to 0, at that time the output is what here? When x of NTS is approaching towards the 0 to delta, at that time which threshold is being selected by this quantizer, either plus delta by 2 or minus delta by 2, means the maximum value of this quantization error is how much here? It is mod of delta by 2. From this quantization characteristics also we can say that, because this is nothing but what? The xq of NTS. As far as this x-axis is concerned, what it is? This is nothing but what? X of NTS. So it is the difference in between xq of NTS and x of NTS. That is nothing but what? The quantization error. Now for sake of moment, when this input is lying in between 3 delta to 4 delta, what will happen? When this x of NTS is approaches towards 3 delta to 4 delta, at that time what will happen? Either it is plus 3 delta, plus minus 3 delta, or plus minus 4 delta. So at that particular instant, which nearest digital value will be assigned by that quantizer? When the input is lying in between plus 3 delta by 2, sorry, when input is lying in between plus 3 delta to plus 4 delta, at that time obviously this is 7 delta by 2. This is the desired quantization level selected by that quantizer. If input is lying in between minus 3 delta to minus 4 delta, at that time what will happen? This is the nearest possible value. Which one? This minus 7 delta. This is the nearest possible value assigned by that quantizer, right? So this is all about this uniform quantization technique, which involves this mid-trade type of quantizer and mid-rise type of quantizer. In both this quantization process, the maximum value of this quantization error is how much? It is mod delta by 2. So I just hope that you had understand all those things which we had discussed in today's lecture. So do not forget to subscribe my channel for further updates in case of this digital communication. Thank you.